Hi everyone, my name's Mark Hardwick. I'm Director of Software Engineering at PyTop. As you all know, Raspberry Pi has enjoyed phenomenal success with makers the world over. I think to date they've sold over 30 million units. PyTop's mission is to make Raspberry Pi even better when used in the classroom. To do this, we created a robust, modular, easy-to-use ecosystem of products that allows teachers to teach while avoiding common problems that teachers encounter when using Raspberry Pi in the classroom, particularly problems with fragility and also time wasting when wiring up things with bare bones Raspberry Pi. The PyTop 4 is really the heart of this ecosystem, and it's an amazing device. You can build a wide range of projects around it, including, of course, rovers, if you have the motors and motion kit, but also musical instruments, weather stations. One of our schools is even using it to replicate the International Space Station. When used within a project build, you can connect to it via any computer, be it a Chromebook, a Mac, or a Windows PC, and that can be a desktop or a laptop. If you prefer, you can purchase the PyTop integrated keyboard and touch-sensitive screen. This turns your PyTop 4 into a fully functioning portable computer, be it for homework, browsing the internet, or doing experiments with the Foundation kit. And finally, if you have a screen and keyboard available, you can use your PyTop 4 as a mini desktop. But no matter how you connect, the full range of free Linux software is available to you, including word processing, graphics, CAD, and of course, all of PyTop's learning challenges, which are available on Further. The PyTop 4 turns a Raspberry Pi 4 into a mini computer that supports learning easily and without any hassle. So this is an informal video that I've put together to introduce you to Further, which is PyTop's learning network. I'm going to run through the features of Further as it is live today, and we'll then also take a look at some of the things in the roadmap. Further is an essential part of the PyTop ecosystem. It provides learning challenges that use the Foundation kit and Motors and Motion kit, both of which seamlessly work with the PyTop 4. Our challenges are structured around our assemble, tinker, play, share learning model. This is a staged model that we use to build people's confidence with making and coding in a series of easy progressions. Our content is also aligned with Raspberry Pi's curriculum. This means schools can make use of the wide range of Raspberry Pi resources while enjoying the ease of use benefits of PyTop. Currently, our challenges focus on the builder and developer stages of the PyTop curriculum, and they'll expand to creator and make over the course of this year. So let's now take a look at Further. We'll go to the live site and I'll show you the functionality in more detail. When you arrive at Further, you'll find a range of challenges available for PyTop 3s and PyTop 4s. There's also a set of tutorials that go through the components of the Foundation kit. When we log in, we find that we can use either Clever or Google Classroom or normal username and password. If you use Clever or Classroom, then you can synchronize your classes and students directly from those systems with Further to avoid having to do any manual setup. I'm now going to log in as if I was a teacher. First thing we'll do is run through the navigation at the top. So you see we have 4 tabs if I'm a teacher. The first, Explore Challenges. So these are publicly available challenges that teachers can use directly or can customize for their own use in class. I'll go into that in more detail later. My challenges is where I am creating challenges either from scratch or customizing the public challenges available in Explore Challenges. Classes is where you manage your classes, and students is where you manage the students in the classes. Let's have a look at one of the challenges in a bit more detail. The first thing you'll see is this large download button. So this allows you to download a PDF of the challenge in case you want to print it off for a handout. I'll show you what that looks like. It comes down as a normal PDF with all the sections laid out nicely, and you can print that off at your leisure. You can switch to read mode if you want to ensure that you don't edit the challenge accidentally. And then we have two buttons, Assign to Class and Publish. If you wish to use this challenge with a particular class, you click Assign to Class, the list of classes come up, and you can assign this challenge to that class. And then students in that class will see the challenge and know that they have to work through it. The Publish button is only visible to very few people. This allows you to publish a challenge back into the public space. And we'll be working with teachers, and when they feel that they want to and they're ready to publish back to the challenge, to the public space, we'll allow them. This allows us to very tightly manage what challenges are public and ensure a very high quality of content. Scrolling down, you can see a number of sections here. Collaborators are people you can work with. For example, if you were a teacher and you had some fantastic ideas for a challenge, but you weren't so strong on coding, you might ask a teacher that was good at coding to collaborate with you, and they could help with the coding sections, and you can write the other sections that surround the coding. Standards can be aligned with a wide range of challenges, which means that in your opinion, this challenge meets the requirements of this standard. For example, the CSTA standards can be applied. In this challenge, we've applied the CTL2 15 standard. There's also a set of teacher resources. All challenges come with a facilitator guide. And let's just have a quick look at that. The facilitator guide or teacher's guide gives useful hints to teachers. For example, the learning goals, what skills are being developed, and very usefully, getting unstuck. PyTop is very easy to use in the classroom, but nonetheless, sometimes teachers might be less confident with teaching coding, and we go through a wide range of things that you might use to avoid problems. Scrolling down, we can look at the way a challenge is organized. So first, let's just collapse these sections. There are a whole series of collapsible sections that make up a challenge. First, we have the kit parts used in an introduction to the challenge. Then we start with our assemble, tinker, play, share model. So we'll have a series of assemble and tinker stages that help the student get familiar with the mechanical and coding aspects of the challenge. And then finally, we move into the play section. And play is where we ask them to do more advanced things, to build on the code that they've learned in the assemble and tinker phases and make something that's customized for their own use and a bit more original. And finally, we ask them to share, to show their work to the rest of the class and see what other people have done. All challenges finish with a set of resources and related projects, tutorials that might be relevant to this actual challenge, and often Python tutorials. Let's now have a look at some of the features of Further. Challenges are made out of code blocks, and teachers, if they wish to customize any of our challenges, can add their own code blocks anywhere or other blocks. So text block, code block, image, file, task, video, or web page. They can all be embedded into the challenge. And of course, you can remove sections from our challenges to help with customization. Let's say, for example, that a teacher didn't want to teach Python, but actually wanted to mix Python and JavaScript. You can set the type of code block and start typing in JavaScript. Of course, colorization follows the language, and teachers can add them anywhere they like. Of course, when they're finished with them or they don't want them, they simply delete. One of the really interesting blocks is the task block, and here we have an example of a task block. A task block allows teachers to ask students to provide evidence of the work they've done for this section. In this case, we're asking them to upload a picture of the assembled timer. Evidence can be in the form of text answers, an image or a file, which could be a video file. Soon we'll be adding the ability to add a code block as a task response. If we have a look at code blocks in more detail, you'll see that they are colorized for the language, and also it's very easy to copy the code so that you can take it over to your favorite editor, be that Move, Thonny or Atom. But even better, Further has an integrated coding environment, and this is really, really exciting. It makes working with PyTorch 4 incredibly easy. What this does is it allows you to connect to any PyTorch 4 on the local network. And then write code and push that code to the PyTorch 4. You can run it and stop it. Now, it may not be obvious here, but what this means is that students can be running Further anywhere, on any device, on a Chromebook, on a Mac, on a PC, on a laptop. They can be running Further, they can be going through the challenges. And when they need to run code, they simply connect to a PyTorch 4 available in the class, push their code to it, and away they go. The code editor is quite powerful. We can, for example, take this code, move this, put it in, and when we run this code, we'll see that on the console it asks us for the number of minutes, and of course we can input an answer. Now this code is running. As you can see, print statements embedded in the code appear on the console as output. And in this way, we can write programs that use the console to input and output data, but also activate LEDs, buttons, buzzers that are connected to the PyTorch 4. This makes coding and learning code in Further extremely easy and elegant for students. Provides a very, very nice environment, and I encourage you to try it out. So now let's leave this and log in as a student and see what the experience is there. I'm going to log in as Georgia. And as you can see, the navigation is now different from Georgia. She can explore challenges, and she has classes. I've added Georgia to 2 classes, Python is Fun and Robotics and Math. And as you'll see, she's the only person in this class, and I've assigned the timer challenge that we looked at before to Georgia. Georgia can now make a submission. She'll start working through getting the parts out that she needs, assembling the components, and then she's been asked here to upload a picture of her timer. Let's do that. There we go. It's a very small picture, but she's uploaded a picture of a timer. And now she might wish to add a comment as well. The teacher can then see this and respond to it. Of course, Georgia has access to the full code editor experience as well. She can connect to the device on a local network, and then run code in the normal way. So that's a quick run through of the features of Further. What I'd like to do now is show you some of the features that we're working on in the upcoming roadmap, and hopefully they shall all be released over the coming quarter. Thanks a lot. Okay, let's now take a look at some of the new features that we're going to be releasing over the next few months. So one of the first things that we're adding is a set of foundation tutorials. So these really help introduce people to Further in a very elegant way, introducing them both to the language of Further and also the sensors and lights and components in their foundation kit. Let's take a look at how that might work. So when you come to the foundation tutorials, you're taken to a series of things. This one is focusing on making use of an LED. So first, connect the foundation plate, connect an LED to the foundation plate, write some code that turns the LED on. So this introduces you to connecting to your PyTop. If there's any problem, we take you to a tutorial. Otherwise, we're connected. We can play the code against the device. And then finally, we're asked to tinker with the code and make the LED behave differently. Once we've finished that, which will take 5 minutes, the user returns. This is clearly marked as done, and they can move on to the next tutorial. And in this way, we introduce them to Further and the components in the foundation kit very elegantly. We're working now to improve the way we present students and their work to the teacher, so that particularly to give deeper insight into progress. So we want to show exactly where the students are and also be able to alert teachers where if there are any groups of students that are falling behind. We're providing teachers with the ability to create and share multi-choice questions so they can support summative assessment to make sure that the learning outcomes are as they expect. We're also about to release integrated messaging. At the moment it's hidden. It is there. We're just adding the finishing touches, and this allows teachers to know, for example, when there are comments that they need to respond to, when challenges have been responded to by students, those sorts of things. We're also adding in the ability to do block coding. So at the moment, Further is predicated on text coding, but block coding will be coming in the next couple of months. And our approach is to make it so that teachers can switch between block and text coding very easily. We think this provides the best benefits. We're also integrating a glossary of terms, so terms such as LED will be highlighted as students will be able to click on it, and teachers, and see a definition for that component or that subject. And that ends my walkthrough of Further. I hope you enjoyed it. Please contact sales if you wish any more information, and I'm very happy to spend more time with anyone if they want a deeper dive into the functionality of Further.